Welcome to the deep dive on LimX Dynamics, the AI-first robotics company that's building what they call physical AI from the ground up. Today we're going to go through every single product they make, the robots, the software platform, the developer tools, all of it. Stick around because by the end of this video, you are going to understand exactly what makes LimX different and why some of the world's most sophisticated investors are betting big on them. LimX Dynamics was founded in 2022 by Will Zhang, a former tenured professor of electrical and computer engineering at Ohio State University. Zhang's goal was ambitious from day one. Don't just commercialize existing robotic ideas, build original technology that challenges the assumption that the US always leads and everyone else follows. The company describes itself as AI first. That phrase gets thrown around a lot in tech, but for LimX it has a specific meaning. They believe the key to useful robots isn't just better mechanics, it's the deep integration of high-level AI cognition with full-body motion control, hardware and software, inseparable from the start. LimX organizes all of its R&D around three core pillars. Pillar 1, hardware design and manufacturing, proprietary actuators, hollow actuator designs, high torque density joints, the physical stuff that lets a robot move like nothing you've seen. Pillar 2, motion control foundation models. This is the AI layer that lets the robot walk, balance, and adapt in real time. It's trained using reinforcement learning, which means the robot gets better by doing, not by following pre-programmed scripts. Pillar 3, the embodied agentic operating system, a full software brain they call COSA. We'll get deep into this later, but think of it as the nervous system and cerebral cortex of every LimX robot, all in one platform. As of early 2026, LimX has raised $296 million across 6 funding rounds. Their latest Series B brought in $200 million backed by investors from the UAE, JD.com, and over a dozen industrial partners. Alibaba, Neo Capital, SAIC Motor, serious money from serious names. They've already begun shipping their flagship humanoid, Ollie, to customers, including a major deployment deal targeting thousands of units to the Middle East for research and industrial use. That's not a prototype program, that's a commercial product. Let's start with the flagship, the product everyone in the robotics world is watching. Meet Ollie. Ollie is LimX's full-size, general-purpose humanoid robot. It stands 165 centimeters tall, about 5'5", and weighs 55 kilograms. It walks, it balances, it picks things up, it navigates stairs and rough terrain, and it starts at just 158,000 yuan, roughly $22,600 for the base model. That is a fraction of what comparable Western humanoids cost. The key innovation in Ollie's physical design is something called hollow actuator architecture, combined with high torque density actuators. What does that mean in plain English? It means the motors inside Ollie's joints are built differently from most robots, in a way that gives them a much wider range of motion and much better balance across the whole body. We've seen footage of Ollie doing things most humanoids simply can't, lying flat on the ground, doing parallel squats, rotating at the waist, and then lifting itself to standing by rotating its legs in a way that human hips cannot physically do. That's not a party trick. It demonstrates the kind of whole-body control that makes a robot genuinely useful in unpredictable environments. Ollie can walk over obstacles, identify and pick up fairly small objects, including tennis balls, and navigate complex terrain. The perception and manipulation systems work together in real time. This isn't teleoperation. This is Ollie thinking for itself. In January 2026, LimX demonstrated what they called the world's first scalable autonomous deployment, a synchronized fleet of Ollie robots powering on in unison. Think about what that means. It's not just one impressive machine, it's a software architecture capable of coordinating dozens of robots at once. That's the infrastructure play. That's the moat. Ollie comes in two configurations. The base model, priced at approximately $22,600, runs only LimX-built applications. The developer version, at nearly double that, around $41,500, opens up the full API, letting developers integrate their own functions and algorithms directly into the robot. That two-tier model is smart. It captures revenue from enterprise customers who just need the robot to work, while also building the developer ecosystem that will make Ollie's platform more valuable over time. Sound familiar? It should. It's essentially the iPhone App Store model, applied to humanoid robots. If Ollie is the production humanoid, Tron 2 is the Swiss Army knife. And honestly, it might be the more interesting product from a pure engineering standpoint. Released in December 2025, Tron 2 is LimX's modular, multi-form embodied robot platform. It's designed specifically for vision-language-action research, the frontier of robotics AI. And it does something no other robot at this price point does. It physically transforms between three completely different configurations. Configuration 1, Dual Arm Mode. You remove the legs, mount the torso on a stand or desktop base, and you have a two-armed manipulation platform. Each arm has 7 degrees of freedom, a 70-centimeter reach, the largest workspace in its class according to LimX, and a spherical wrist inspired by the human wrist. Payload, 10 kilograms total across both arms. Configuration 2, Bipedal Mode. Snap on the humanoid legs with flat sole feet, and Tron 2 becomes a walking biped. It uses visual-based motion planning to navigate stairs, up to 20-centimeter step height, and can handle varied terrain. This mode is designed for locomotion research. Configuration 3, Wheeled Mode. Swap the feet for wheels, and suddenly you have a fast, stable, all-terrain mobile robot. The wheeled configuration supports up to 30 kilograms of payload, triple the arm-only mode, and includes auto-recharging capability. This is your logistics and inspection platform. The switch between modes isn't just mechanical. The software automatically recognizes which configuration is installed and loads the corresponding motion control algorithms. No manual software configuration. You swap the hardware, the robot adapts. The EDU edition of Tron 2 is particularly powerful for developers. It runs on an 11th Gen Intel Core i7 processor, includes 2 terabytes of storage, and offers 4 Ethernet ports plus 4 USB 3.0 ports for sensor integration. It ships with full Python and C++ support, ROS 1 and ROS 2 compatibility, and URDF files for simulation in NVIDIA Isaac Sim, Mujoko, and Gazebo. It even comes with preloaded tutorials for cutting-edge VLA algorithms like ACT and Pi 0.5, backed by over 1,000 real-world datasets. LimX claims you can go from unboxing to running a VLA model in under 2 hours. For a research lab, that's transformational. Tron 2 also supports VR teleoperation via Oculus Quest 3, meaning researchers can puppeteer the robot in real time to gather training data. That's the data flywheel that makes better AI models, which makes better robots. The EDU Dual Arm Edition starts at $20,000. The full 3-in-1 kit, arms, legs, and wheels, is $25,000. For a research platform that can do manipulation, locomotion, and mobile robotics out of one box, that is an extraordinary deal. Before Tron 2, there was Tron 1, and it's worth spending time here because Tron 1 tells the story of how LimX learned to build. Launched in October 2024, Tron 1 is a compact bipedal robot, 854 millimeters tall, under 20 kilograms, that became the first publicly available multimodal biped robot designed specifically for humanoid reinforcement learning research. At $15,000, it opened up a corner of robotics R&D that used to cost 10 times as much. The defining feature of Tron 1 is its modular foot-end system, what LimX calls a 3-in-1 design. The same robot body can accept 3 different types of feet. Point foot mode gives the robot a simplified minimal contact point, like a peg leg. It's the simplest configuration for studying fundamental locomotion. Soul mode adds flat humanoid-style feet, enabling standing and walking in a form factor that mimics human gait. This is your test bed for humanoid walking algorithms. Wheeled mode replaces the feet with rolling wheels, and here's the impressive part. Even in wheeled mode, Tron 1 can still climb stairs. The robot figures out how to combine rolling momentum with its leg joints to get up elevation changes that pure wheeled robots simply can't handle. Tron 1 was built around a simple idea: lower the barrier to entry for robotics research. It runs Python natively, no C++ required. It has automatic hardware recognition that detects the installed foot configuration and loads the right algorithms automatically. The SDK is fully open. It connects to every major simulation environment. It's the robot that taught a generation of researchers how to think about multimodal locomotion, and it's the direct ancestor of Tron 2, which took everything Tron 1 proved and turned it into a full-scale platform. Before before Tron 2, there was CL1. This was the proof of concept, the robot that showed the world LimX's motion control technology wasn't just impressive in a lab, it worked in the real world. Demonstrated publicly in August 2024, CL1 showed something genuinely remarkable for its time. A humanoid robot loading heavy objects continuously, adopting multiple postures, adjusting its grip in real time, and recovering from external disturbances, all while maintaining balance. CL1 was the foundation. Ollie is the product. Everything LimX learned building CL1 is baked into every robot they make today.